The star Betelgeuse, a red, stunningly enormous monster found in the splendid heavenly body of Orion, has long stunned stargazers and cosmologists alike because of its sheer size and magnificence. If Scarab Jews were placed where our Sun is, it would grow to the orbit of Jupiter, exhibiting its titanic size. Regardless of being situated around 642 light-years from Earth, its gigantic scope makes it one of the most exceptional stars apparent to the unaided eye. Curiously, Betelgeuse has shown odd behavior, such as astounding dimming and brightening cycles, which many specialists believe signal that the star is approaching the finish of its life. The notable physicist Brian Cox recently offered a huge statement that Betelgeuse is nearly an amazing blast, expected to happen within the next 14 days. This event, known as a cosmic explosion, will mark the finish of Betelgeuse's life. However, it will offer an uncommon and entrancing opportunity for researchers to study one of the most impressive celestial phenomena known to man. As a red supergiant, Betelgeuse is one of the largest and most monstrous types of stars. It has been on astronomer radar for many years, but its recent surprising changes in brightness have sparked speculation that it is preparing for a significant explosion. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, triggering a massive explosion that releases enormous amounts of energy, radiation, and material into space. Betelgeuse's impending blast is anticipated to be a Type II supernova. This particular type of celestial event occurs when the core of a massive star implodes. The collapse releases neutrinos and radiation, creating a shockwave that destroys the star. The explosion will be so brilliant that it may be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would be catastrophic if it occurred near Earth, Betelgeuse's distance of around 642 light-years ensures that the blast, although dramatic, poses no risk to life on our planet. Instead, the event promises to reshape how we understand supernovae and other cosmic phenomena. A supernova is perhaps one of the most powerful events known to man, releasing more energy in a few seconds than the Sun will in its entire lifetime. Betelgeuse's blast won't just be a spectacular cosmic display, but also a crucial moment for science. Scientists are eager to observe this unprecedented event from its earliest moments, using a range of ground-based and space telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse detonates, it will emit a broad spectrum of radiation, from visible light to gamma rays. One key aspect of the explosion will be the release of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion due to their ability to pass through almost anything without being affected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, giving an early advantage in tracking Betelgeuse's final moments. The blast will also provide valuable insights into the production of heavy elements. When stars explode, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give researchers a clearer view of this element production process, which is vital for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is unlikely to negatively impact Earth, it will interact with our planet's atmosphere and magnetic field in interesting ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could lead to more intense auroras, expanding the regions where the northern and southern lights are visible. Although these powerful rays could temporarily affect satellite communications and some technologies on Earth, the disturbances are expected to be minor and short-lived. Perhaps one of the most fascinating aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For a few months, or possibly longer, Betelgeuse is expected to be the brightest object in the night sky, potentially even visible during the daytime. This event won't just excite professional scientists, but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Scientists have long hypothesized about Betelgeuse's end, but Brian Cox's recent statement adds urgency to the matter. Observatories worldwide are preparing to monitor every phase of the cosmic explosion, and the data collected will be invaluable, potentially changing our understanding of celestial evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, It offers a unique opportunity to measure how energy from such an explosion travels through space by observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars. Astronomers will gain a clearer understanding of the size of the universe. The event will also provide a rare opportunity to study dark matter and its potential impact on the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, seeing how light and matter behave around Betelgeuse after its explosion could give indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the creation of elements essential for life. Supernovae are crucial, massive events responsible for spreading heavy elements throughout the universe, elements that ultimately form new stars, planets, and even living creatures. By studying Betelgeuse, researchers will gain valuable insights into how these elements are created and distributed. The cultural significance of Betelgeuse's explosion is also important. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will prompt philosophical reflection on the transient nature of the universe. In some cultures, such cosmic events have been interpreted as signs of great change. Betelgeuse's blast could evoke a mixture of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and cosmology, bringing more people into the quest for knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to. Universe. In scientific terms, Betelgeuse's explosion will provide a crucial benchmark for refining existing models of stellar evolution and supernova mechanics. By comparing ongoing observations of Betelgeuse with simulations and theoretical predictions, scientists will gain valuable insights into the processes that govern the life and death of massive stars. These insights will have far-reaching implications, impacting fields ranging from astronomy and cosmology to planetary science and even astrobiology. The event will also serve as a unifying moment for global cooperation in science. Astronomers, physicists, and researchers from around the world are already preparing to share resources, observations, and data in real time to maximize the scientific return from this once-in-a-lifetime opportunity. This collective effort will showcase the power of international collaboration in the pursuit of knowledge. Betelgeuse's blast will also have significant educational value. Schools, universities, and public observatories will seize the opportunity to engage students and the public in discussions about space science. Outreach programs and live broadcasts of the supernova will inspire a new generation of scientists, engineers, and thinkers, sparking interest in STEM, science, technology, engineering, and mathematics fields. Ultimately, the supernova will reaffirm humanity's position in the vastness of the universe. It will remind us of our shared existence on a small, fragile planet orbiting an unremarkable star, while offering a glimpse into the greater forces that shape the cosmos. Events like these connect us to the past, as the light from Betelgeuse's explosion will have traveled for thousands of years to reach us, and to the future, as the remnants of the supernova may eventually contribute to the birth of new stars and planets. The light from Betelgeuse's explosion, which has traveled through space for thousands of years, will not only serve as a reminder of the vastness of time and space, but also as a beacon for future generations of scientists and explorers. The remnants of the supernova will scatter heavy elements into the interstellar medium, potentially contributing to the formation of new stars, planets, and even life. This cycle of birth, death, and rebirth in the universe underscores the dynamic nature of the cosmos. As the explosion unfolds, it will provide new opportunities for research that may lead to groundbreaking discoveries in astrophysics, helping us better understand the life cycle of stars, the formation of galaxies, and the distribution of matter in the universe. In the long run, the knowledge gained from studying Betelgeuse's death could help answer some of the biggest questions in science. Questions about the origins of life, the fate of the universe, and the fundamental forces that govern existence. Moreover, Betelgeuse's impending explosion represents a moment of unity for humanity. It will draw attention to the shared curiosity and fascination that we all have for the cosmos, transcending cultural and geographical boundaries. People worldwide will be united in observing a celestial event that, though taking place far from Earth, will have a profound impact on our collective imagination and understanding of the universe. The event will also offer profound philosophical reflections on the nature of existence. The death of Betelgeuse, one of the most visible stars in the sky, will prompt us to consider our own place in the cosmos, the transitory nature of all things, and the meaning we assign to the universe around us. It will ignite a sense of wonder and introspection, reminding us of the fragility and beauty of life, both on Earth and in the vast, expanding universe. In the years to come, Betelgeuse's supernova may become a symbol of cosmic exploration and a landmark event in the history of astronomy. It will be remembered not only for its dazzling display but for the scientific, educational, and philosophical legacy it leaves behind. As a defining moment in the study of stellar evolution and the universe, it will continue to inspire future generations to look to the stars, seek knowledge, and explore the mysteries of the cosmos. As the dust settles from Betelgeuse's spectacular demise, its legacy will continue to ripple across the scientific community. The insights gathered from the supernova will spark new questions, encouraging scientists to refine their models of stellar evolution, the formation of galaxies, and the behavior of matter in extreme conditions. Researchers may uncover new mechanisms that drive the dynamics of supernovae and explore the long-term effects of such explosions on the surrounding interstellar environment. The study of Betelgeuse's final moments will also likely provide new insights into the enigmatic behavior of other massive stars that are nearing the end of their life cycles. Scientists could apply what they've learned from this event to better understand other stars in similar stages of evolution, thus enriching our knowledge of the life cycles of the most massive stars in the universe. By observing how matter is expelled during the explosion and how the surrounding environment reacts, astronomers may also learn more about the processes that shape the formation of new stars and planetary systems. In addition to its scientific value, the explosion of Betelgeuse will continue to fuel the human drive for exploration and discovery. This celestial phenomenon will remind us that, despite all our technological advancements, the universe still holds mysteries far beyond our understanding. The event could inspire a renewed sense of wonder, encouraging future generations of scientists, engineers, and innovators to pursue careers in space exploration, astrophysics, and related fields. The opportunity to witness and study such a dramatic cosmic event will also reinforce the importance of international collaboration in scientific endeavors. The global effort to track and analyze Betelgeuse's supernova will set an example for how countries and institutions can come together to tackle complex challenges. By sharing data, observations, and resources, researchers from across the world will work toward a common goal of understanding one of the most significant events in our universe's history. On a more personal level, Betelgeuse's explosion will deepen our connection to the cosmos. It serves as a reminder of how intricately we are woven into the fabric of the universe, as the elements created in stars like Betelgeuse eventually contribute to the formation of life on Earth. The energy released in such explosions scatters the building blocks of life throughout space, ensuring that the legacy of each star lives on in some form, whether as part of a new star, a planet, or perhaps even the life forms that may inhabit those planets. As time moves forward, Betelgeuse's supernova will remain a beacon of curiosity, science, and philosophical reflection. Its death will inspire us to ask bigger questions about our place in the universe, the nature of existence, and the forces that govern our cosmos. Whether in the pages of textbooks, the reports of scientific discoveries, or the stories shared across generations, Betelgeuse will live on as a testament to the grandeur of the universe and our unending quest to understand it. Ultimately, Betelgeuse's explosion is not just a cosmic event. It's a reminder that even the most massive and brilliant stars must eventually meet their end, making way for new beginnings. It underscores the ongoing cycle of